So we're going to be going through another question. This is going to be October 2020, question 18, part B, which focuses on work done and energy transfer. I'm not going to be doing part A. That's going to be going into the momentum playlist. Basically, you don't even have to know about part A to be able to answer part B. So I'm just going to straight go to part B and we'll just deal with part B itself. So basically we have a disk and the disk is moving up this inclined plane, and the inclined plane is at an angle of 30 degrees, and the disk moves up, and yeah, let's see what the question says to us. Okay, and then it says that the disk here is at a velocity of 5 meters per second, and the disk will move up this ramp. And then we have to see that the disk moves up and the work done by the disk against the frictional force. Okay, so work is done by the disk against the frictional force. So basically, disk is moving up, it's doing work against the frictional force. And then it says the disk moves a distance of 6.5 centimeter up the ramp before moving back down. Okay. So what's actually going on here is the disk has a kinetic energy. So it has a kinetic energy, and this kinetic energy is being converted to, or basically we are losing this kinetic energy and it is being converted into the work done against friction. Okay, and then kinetic energy is also being converted into the gravitational potential energy because the height is going to be increasing. Okay, so you can imagine it like this. As the disk moves up, it's going to give its energy, it's going to give its kinetic energy to do work against the frictional force that's trying to move it down, and it will also change its kinetic energy into the gravitational potential energy. Okay, now it will reach a certain distance, it will travel a certain distance until all of this kinetic energy has been converted in different proportions to GPE and work done against friction. That's when your kinetic energy is zero. All of it has been converted into these two things. That's when your KE is zero and your velocity is also going to be zero. And after that, you'll reach a point where the disk will start to move down when all the KE has been lost. So that's when your disk will start to move down. So now let's look at something. So basically, the disk moves up a distance of 6.5 centimeter up the ramp. And when it reaches 6.5, after that it falls down, which means at 6.5 centimeter, it loses all KE. Once it loses all KE, velocity becomes zero, it falls down. Okay? Does this make sense? As it goes up, it's losing KE. Where is that KE going to? To GPE and work done against friction. After traveling 6.5 centimeter, its KE completely becomes zero, all of it is gone, and then it falls down. So I can say when it travels 6.5 centimeter, when the disk travels 6.5 centimeter, I can say all of the KE has gone into GPE plus the work done against friction. I can really use this equation, and it's going to be really handy, and this is the main equation that we'll be using in this question. Okay, now what we can do is we can say this is, by the way, the initial kinetic energy. Okay, and then we can say that the initial kinetic energy is half mv square is equals to mgh plus the work done against friction. What do we want to find out? We want to find the frictional force. Okay, and then I can say the work done against the frictional force is the frictional force itself times the distance traveled. Okay, and then we have to find this F here. Alright, now first I need to find this vertical height, because for MGH, so I'm going to need that vertical height right there, and that's going to be 6.5, I think it's going to be sine 30. And I can further write it as 6.5 times 10 to the raised power of minus 2 sine 30. So that's going to be the vertical height. And then I think they've already given us the mass in the previous part. Yeah, mass of disk is 0.035 kg. So 0.035 kg. I've plugged in this value, and also the velocity they've given you in the start of the question, 5 actually, 5 square. So this should all equals to force times the distance traveled. Okay, so let's just find this out. You're gonna get 0.43 joules is equals to the frictional force times the distance traveled. Okay, remember the frictional force is gonna be acting in this way. This is going to be the frictional force to oppose the motion. So frictional force always acts along the surface. Okay, this is going to be the frictional force. And the distance will be parallel. When you use work done is equals to F times D, this both must be parallel. Okay, so we'll use the parallel distance, which is 6.5 times 10 to the power of minus 2. So 0.43 is equals to frictional force times 6.3 times 10 to the raised power of minus 2. So the frictional force is going to be equals to 6.6 newtons. We'll round it. Okay, so that's going to be the answer. Okay, it might appear at first to be a hard question, but there are so many questions like this, so just do a lot of these from the playlist and from your worksheets that your teacher gives you, and it shouldn't be that hard by the end. At first, when you probably see this, it will be very hard, especially coming out of IGCSE, right? So anyways, that's my comment on this, and that's all.